Okay, according to my clock, it's 3:40. This session may be a little shorter, maybe a little longer. I actually haven't given this talk before, so we'll just play it by ear and see how it goes. So I thought it'd be good, after talking with your advisors last year, to give a session about web architecture. And before I do that, I want to let you know who your advisors are. So actually, there are a couple of tutors and advisors here. I think you know some of them, and some of them who are leaders of your particular EGs are here. Many of them are not here. Again, as I said earlier, they're overseas or not able to join us today because they're on internship. So all of you who are advisors or tutors, can you quickly stand up and introduce yourself? I'm going to pass you the mic. Let's start with the ones over here.
Hello, everyone. Hello, everyone. I'm actually a tutor for the workshop later for Android. Talking about myself, my name is Jquery. I'm from year 2 going year 3, information systems for state, and I participated in Orbital 24 days. So the experience was fun, and I hope you all have fun. Thank you.
Hello. I am Benjamin. I'm a tutor for Orbital this year. So as you might know, I'll be giving a workshop on Meteor, which is a web framework in JavaScript. So about myself, well, last year I did Orbital. I was one of 4 Apollo 11 teams, and I was mentored by Schumer, who is now the he is a researcher at NUS. So I'm also interning at OMAS, which is a startup, a health startup, and yeah, that's it. I'll be going for NOC in Silicon Valley. So if you have any questions about that, you can come and find me.
Hi, I'm Justin. I'm one of the advisors. I took part in the very first Orbital. This is my 2nd year returning as an advisor, so I'm really looking forward to what kind of project concept to offer. This is a really big group. I trust that some of you have awesome ideas that it's guaranteed to go on the way. So yeah, I can't wait to see what you guys have to offer for us. Thanks.
Hi guys, I'm Solid. I'll be here to consider that. I did Overflow last year. Yeah, I'll be teaching Jquery and JavaScript. You should consider.
Hi, I'm Wilson. I'm an advisor here, so my age should be around there. Hi guys. So yeah, I did Orbital last year. I'm a Project Gemini. And this year, other than being an Orbital advisor, I'm under Google Summer of Code. I'm working on this app called Teammates. If you're taking CS Technology, you know what it is. So yeah, other than that, you want to ask about Google Summer of Code, you can ask me also. Okay, that's all.
Hi guys, my name is Dan. I'm also an advisor, computer science year 2 going 3. I did Orbital last year, and hopefully I'm looking forward for new ideas from you guys and waiting for tomorrow when you guys show off your ideas. That's it.
Have a big round of hands for our advisors and tutors. You know, these guys and girls who are helping all of you are really brave. You know, they're taking a lot of time to evaluate and help you out. And it's our hope, our fervent hope, that you learn their faces and you make SOC a more friendly place. We know going through 4 years here is really tough. You just barely survived your first year, right? So, you know, having some friends and some seniors around can help you out. They can give you some ideas about how bad Prof. Khan's class is, etc. You know, when you take our modules seriously for academic credit, right? Okay, so I just want to, again, plant it as a seed in your mind that as you go forward, you know, we want SOC to be really a vibrant family. And I think you've heard some of the graduating seniors say they really like the SOC experience because it's been a productive time together. And I hope you won't not get a chance to meet your advisor and the other people who are helping you out and your teammates who are going together through your Orbital journey being in your evaluation group. So really, we want Orbital to be a really formative experience for you, something that you're self-directing over the summer, but a chance for you to have this cohort effect, which means that everyone else in this room is going over the same problem, same initial passion, and then lots of struggling with development. All of you are doing it together. So it's a very different experience than doing it completely on your own. This is why we're doing it as a module. Okay, so from the feedback we got from our advisors, I actually had a session in February, a long time ago already, where we talked about what we can improve on Orbital over the last iteration. And again, we'll do this again this year. But basically what they said is that at the very beginning, there's a lot of technical stuff that we're going to throw at you. And we don't expect you to get most of it. Okay, it's going to go fly by you. Some of you will be able to absorb it, no problem. But most of us will not be able to get it all. So one of the things that really helps, I think, cement it all together is to understand how is it that the web actually works. What happens when you press a button on your computer and you get a web page? All right. So we're going to try to cover that so that you have some inkling about what happens there. Okay, this is a really, really complex slide. It's taken from Wikipedia, but it basically gives all the nuts and bolts about what happens when you give a web page. Okay, so I'm not going to go over a lot of this. I'll just point out at this particular time that there are a number of different things that we consider as part of what's called a stack. Okay, so you may have heard of a stack, but basically it's the stuff that you see in the white letters. So a lot of people, for example, Amazon and Google, they all run their version of an operating system called Linux. Does everyone here know what Linux is? Yes? Anyone doesn't know what it is? It doesn't matter, okay? It's just another operating system besides Windows or Macintosh OS X, okay? Just another way to run your computer. So Linux is a popular operating system for servers, okay? And when you build a web framework, sometimes you might use a server as your deployment machine. So you won't actually run it on your laptop. You run it somewhere in the cloud, like they say, okay, located somewhere else. If you happen to be running Google App Engine, your application is running somewhere in Jurong West. Okay, that's where Google's Southeast Asia data center is. It's near the Hawker Center, one of the Hawker centers in Jurong West. Okay, I can point it out to you another time. Okay, anyways, besides having the operating system which you have to interact with, most of our applications are web bound, right? They're driven by a web server. So there's a piece of software that exists on a computer, which you can download and install on your own laptop as well. It's called a web server. Basically, its job is to serve up web pages or to react to web requests. Okay, so there are lots of different web servers that you might have heard of. One very famous one that's the most Swiss Army knife of all of them is called Apache Web Server. Who knows why it was called Apache? Anyone happen to know? Yeah? No idea. Apache is an Indian tribe, an American Indian tribe in the US, but that's not why it's named that. It is because when people first built web servers, they just cobbled it from pieces of bits of code from other places. They patched it all together. So they called it an Apache web server, okay? Because it was all like cobbled code. They didn't actually sit down and formally write things like we would do with Agile or with the waterfall model. So they patched it together So it's stuck. It's called Apache Web Server. And then subsequently they rewrote it, but the name stuck. Okay, so now we're on version 2 of the web server, Apache. There are lots of other ones. So especially those of you who might be using, for example, Ruby on Rails, you might come across something called Nginx. That's the other one that's mentioned up there. So just understand that within an operating system, there is a web server. Okay, so those of you who run Microsoft products like Microsoft Windows, you can install a web server that's native from Microsoft called IIS. That's also another popular web server. Okay, there's another part of what a stack means, and that's a letter for the type of programming language that's used to service a request. Okay, what I mean by request is, for example, when you press a button and you want to add a record to the database. For example, I'm on Facebook, I type in something, or I'm on Slack, I type in something, I press return. Okay, it uploads my data somewhere, and then it gets disseminated to all of you, for example, through Stack. Okay, all of that has to be written by someone, right? The logic for that, and that is another choice that you have within your stack. Okay, so typically you'll hear that you can use Python, one of the P's, PHP, which is an older language that a lot of people know from the older generation, Perl or Ruby. These are all languages. They're programming languages that you can use to write web programs. Now, you all have probably not learned so much Python or any of these languages before, but you've probably heard of Java or taken Java classes or C, right? You can use those languages too, okay? Any programming language can be used as a web application programming language. In fact, there are many, many, many choices that you have. And hopefully I'll be connected in a minute. Okay, but we can look at Wikipedia for all of these things. You guys are playing games, aren't you? Is that why my connection is so slow? Man, it's slow. I'm glad I'm on PowerPoint. Okay. Anyways, we'll get back to that. And the final part of a stack is usually a database. Why a database? Because when you are storing information that users are uploading or interacting with, you need some way storing it, right? So we don't store it in text files or something like that. We have to store it in a structured repository, and typically we store that in a database. So there are a number of choices. To get into that. Okay? All right, so this diagram doesn't make a lot of sense to you now, but the point about this is when people refer to a stack or a web framework, they're thinking of these 4 objects, okay? Usually meaning the operating system, okay, the web server, the language that you're writing the web application in, and the choice of database that you're using, okay? So for example, if you're going to do Google App Engine, Python, okay, you're going to be using probably a Linux system, okay, or your Windows or Macintosh if you have it. It doesn't fit nicely into one of these. So why is the term full stack important? It's because when you look at people in industry, either in the US or in Singapore or other places, people really are looking for full stack developers. A lot of them are, okay, especially startups. What does that mean? If you go to Stack Overflow, this is a site, if you don't know already, you will love by the time you finish Orbital, okay? Definitely, definitely, definitely. Okay, so if you have bugs or questions, you go to Stack Overflow and you find answers to that, and you're going to learn a lot more. But the point about this is that when you think of what type of job you want to get, okay, there are people all the time looking for full stack developers here in Singapore and elsewhere. Okay, so what types of stacks are there? Well, I already told you some of them, right? One very popular one is called the LAMP stack. It means Linux, Apache, MySQL, and then any one of these P languages, okay, Perl, PHP, or Python. So if you Google and you find the word lamp all in uppercase, you want to know what it is, that's what it means, okay? It means this combination. It's like a menu. You choose one of every component. I choose Linux as my operating system. I choose Apache as my web server. I choose MySQL as my database. And I choose, let's say, Python as my scripting language or web application language. There are other ones, especially for those of you who are thinking of doing Apollo 11, are doing things that are not that standard. For example, if you want to make a live application that responds in real time, like a chat application, okay, then you might consider the architecture on the right. The right, for example, is MongoDB, Express, Angular, and Node. These aren't the same choices of operating system, etc. But these are different types of technologies that you can use in the last 1 or 2 years. Okay? This will help you create applications that are very good at managing live communications. Okay? If you want to know more, again, just click on the link and you can get some comparison. There are a lot of web pages on this, of course. Okay, I want to diverge a little bit and give you a history lesson of sorts. What the web used to be and how did it come to where it is now. Okay, so in the beginning, sites were static. Okay, who knows where the web was first developed? Which country had the first web page? Was it Singapore? No. Anything here? I'm kidding. Okay. Where did these come from? 2 different countries developed the web. Okay, maybe you've heard of Tim Berners-Lee, the originator of the web. Right? He was originally a physicist. Right? He was assigned to help particle accelerators communicate their data. So it was actually developed in a place called CERN, C-E-R-N, a particle collider in Switzerland. Okay, and they actually had to collaborate with the NCSA, that's the National Computer for Supercomputing Applications. It's in the USA. Okay, so they had to communicate documents between each other, and they thought, well, you know, the way that we're doing it now, back in 1990, okay, around when you were born, okay, was not very efficient. Okay, so they came up with this idea called HTML, okay, Hypertext Markup Language, which we're going to go over the second half after this part. And created what we now know as the web page. Well, it's not exactly what we know now. Okay, back then it was a lot simpler. Okay, sites were basically just text files that had some simple markup, which when you ran through another piece of software called a web browser, which you are all using now, okay, allowed you to see a graphical version of text, okay, in images. So there are lots of things about this, you know, they look like this on the left-hand side, okay? Basically, very simple pages that had a lot of nice properties that they could be cached, meaning that somebody could save a page and then serve it to someone else without going to the original website. They could be indexed, meaning that, for example, Google or other search engines could send programs to get those pieces of information and then construct an index to help people search, okay? But of course, you know, these web pages look really drab. They don't update. They are not dynamic in any sense. They don't respond to anything besides clicking on hyperlinks. So after that, quite early on, they developed another technology called Common Gateway Interface. Now, no one really knows what this means anymore. But basically, this is where people started to be able to submit data back to the web. Okay? Maybe some of you have heard of Web 1.0 called the static or the read-only web. That means back when the pages that you saw, you could never interact with. Okay? Like, for example, you just read some information off of the web without ever being able to submit a form or offer feedback. Okay? Or like a page or favorite a page. Okay? But now, after the introduction of CGI, you could submit forms, meaning that you could interact with the website, send information back, and the website could react to you in some way. Okay? After a while, people got more dynamic. Okay? they decided that that wasn't enough to submit things back to the server. Okay, because what happened when you click an upload form to upload a file or to send the form, that data has to travel back from your computer back to the server wherever it was, in the USA, in Singapore, in Japan, in China. Okay, so they introduced the notion of JavaScript. Everyone knows Java, right? Or has heard of Java? Okay, JavaScript is a derivative of Java. It's not exactly the same at all. Okay, what's a version of Java on web pages? Now, that gives a very different experience because now dynamic action is being introduced on the client. Okay, client, meaning your particular MacBook, your particular Asus laptop, your particular Dell notebook or Samsung Ultrabook is running code to make your web page, the web page that you downloaded from that site, dynamic. Okay, you see this all the time. Practically almost every web page that you see has JavaScript built into it, right? If you go to our homepage at the School of Computing or any faculty's homepage, they have all JavaScript inside, right? To make the animations flow, to do other things, okay? Okay, originally JavaScript was just used for simple scripting for validation, for these really annoying things that we had in the early 2000s, pop-up advertisements, and to make annoying other special effects like cursor trails like I'm doing now, okay? Okay, and more recently you may have heard of the term Ajax. Who here has heard of Ajax? Okay, some advisors. How about the rest of you? Okay, Ajax is a technology that allows the web page to update from the server without the server, without you needing to refresh the page. Okay, so for example, if you're looking at Facebook or you're looking at Slack on the web, all right, those things dynamically update. That means the page changes without you doing anything, right? After a while, it says new stories or new notifications. Those are pushed from the server. That means the server, wherever it is, knows that something happened and then sends information to your browser. Okay, your browser then says, oh, something new happened. I better go put it up on your web page. Okay, and then you see it changing. Okay, so that is a big change. It was sparked by Google Maps. So when Google built Maps, when you have to scroll around and pan in the Maps toolbar, it needs to be able to load more data. Okay, but it's not going to load up the entire map for you at one time, right? It needs to be able to do it on demand. So that's where that idea came from. Okay, the problem with all of these new web technologies is it becomes possible, very difficult to do certain things because, for example, if I am Google or I'm a search engine, and I want to be able to pull that information down and store it, okay, to index it so that I can help other people search it. I can no longer do that because I don't know how to get those dynamic data down. It's not visible to me. Okay. All right, so I'm going to switch gears for a second and show you some other slides from one of our other courses. See whether I can find it. Okay, so we have a really, really talented lecturer. His name is Stephen Halim. He teaches our web programming and applications, which is a follow-up to this course. So if you find that you love web technologies, you want to learn more about it, you can hear part of the lecture here and then hear him give a much better, more improved version of it when you get to his lecture. Okay, so his slides are in HTML, so I don't have a PDF of it. So we're just going to go through them. I've already shared the link in Slack. Okay, so HTML and HTTP is basically worked on this paradigm called client-server, right? We've already talked about that. That just means that I have a client computer, let's say this notebook here, and I have a server somewhere else in the world, and I want to talk to each other through this protocol called Hypertext Transfer Protocol, right? Why is it called that? Because it's a protocol for transferring hypertext, right? HTML. Okay, so it's called HTTP. That's why in front of all of these browsers here, actually at the front, when you copy that link, you put it somewhere else, you'll see the letters HTTP. Okay, that's what it stands for. Okay, so how does it work? The client first has to initiate contact with the server, right? So you have to be able to request the web page, right? So just now I pressed the key. It went off to the server in our computing room in COMP NUS EDUSG and fetched the next slide, okay? And then the server responds, okay? By giving the web page back to us, right? So it could send the requested web page back, or it could deliver email, whatever you want. That's the client-server paradigm. So for a protocol to exist, we have to understand that it has to share the same standard for the client and the server for it to be able to talk. Okay? So the one that we're going to talk about today a little bit more in depth is HTTP. What does it mean, okay? So very important, HTTP is a connectionless, stateless protocol that allows a web server and a web browser to communicate. This is going to change, but for right now, we're on HTTP 1.0. That's what's happening, okay? Both the request and the response looks a little bit like this. There's some piece of information at the beginning, a head, then an empty line, a carriage return line feed, okay, and then the body of the request that's sent later. So this is just a packet of a text message that's being sent. Not necessarily text, it could be binary. Okay, so for an HTTP request, let me blow this up, let's see whether it'll work. Nope. Okay. For an HTTP request, that means when you request a web page, what happens? Okay, the initial line that gets sent is called a get, a head, or a post. Okay, it's the form of the request that we're asking the web server to respond to. Okay, the header specifies other pieces of information, including cookies. Okay, we alluded to cookies earlier. I'll talk more about them in a minute. And the body of the request contains any other piece of information that I want attached to the request. Okay, when I say connectionless and stateless, what it means is that when I service a request at the server, it has no idea of who I am. Okay, no idea at all. When you request 2 pages in succession, actually the server doesn't keep records normally about your first request. Okay, so for example, let's take IVLE as an example, all right? You log into IVLE, you get a web page back, okay? Then you click on a button in IVLE or a hyperlink. You send another request to the web server. Does the web server remember that you're logged in? Sure, right? It does. But actually, there's a request that is sent to the server remains stateless, connectionless, meaning that the web request itself doesn't have any information about who you are or how you're authenticated. Okay? How does it keep that information if the transfer protocol does not? It does this through something called cookies. Okay? Cookies are not something that you eat for snack, right? Actually, in our web world, it just means some small piece of information that I associate with this request. Okay? So when I make a request to IVLE and I want to log in, okay, what happens? Okay? The server realizes that I'm Min, okay? My name is Min. It saves the information that of my session associated with a cookie. All right? It sends this cookie back to my web server, my web browser on my machine. And then subsequently, when I want to request something from IVLE, I have to offer this cookie back up. Okay? I have to offer my login credentials again and again and again every time so that the web server still remembers who I am. Okay? It's like the web server has amnesia. Oh, I've seen you before? Really? I don't know you. Okay? So every time you have to give the web server some information about what session you belong to. So if you go to a website and you hear, oh, by the terms of keeping cookies on your website, on your web browser, that's what it means. It's saving state information about what's going on. Okay, you probably know some of this stuff already, right? What's the definition of a URL? It's called a Uniform Resource Locator. In other countries, it's called an URL. Here in Singapore, we call it URL because we like acronyms. Okay, and they just look like this, right? There's an indication of what protocol is being followed, right? So we call it a Hypertext Transport Protocol. Then we port number, and then some path that tells us what web page is being looked at. And then in some cases, I might have a query or a segment. Okay? Okay. Many requests that we send to the server are requests that include certain types of parameters. Okay? They're called query strings. Okay? So for two different actions called get and post, okay, sometimes you can append information to say something about what you want. This, okay, let's go get. This is post. Where's that? I promised to show you web applications. Now I finally loaded after half an hour. Okay, so hopefully I'll be able to show you that later. Okay, while that's loading, we'll talk about get and post. Okay. Primary actions that we do with web servers. Okay. The first is called get. Get is exactly what it sounds like, right? It means get something from the server, retrieve a resource from a server. So when you, for example, type in a URL and press return on your browser or click your favorites or whatever, you are getting a web page from the server. You're asking the server, can I have that web page? Can I have a digital copy of it? And the web server says, sure. Okay, I'll send you the whole thing back, and you get the request. Okay. Now, in other cases, you may want to post something to the server. That means have it react to you in some way. Okay. For when you submit a form, okay, you send some information back to the server. We use a post request. They look a little different from each other. Okay. And one thing that you should do is in your favorite browser, you can open up your developer console. I know probably you don't look at this very often. Okay, so in Firefox, you have this thing called Web Developer. You can activate that. Okay, console. Okay, and you'll see something like this underneath. Okay, and you can get information about what things happen. Okay, so for example, if I request a web page, let's say, I don't know what's going to. Okay, so you can see here, for example, there's the word get, right? All the 200 get. Okay, get means that the server has been asked by my laptop to get a web page, right? And in fact, it didn't just get this web page. In fact, Ivy League, even the home page relies on a lot of different files from that. So for example, it relies on something called main.css. This is the cascading style sheet to make Ivy League look the way it is. Okay, maybe you don't like it very much, never mind. Okay, it also has some JavaScript files that are downloaded. All of that you can see that is actually being retrieved. Okay, you can see how long it takes to retrieve. The important part here is that when you request a web page, you're just getting the page itself. But many times, especially in the next lecture when we're talking about web basics, about HTML and CSS, we have to rely on other files as well. So after we get this basic web page from the server, the client, meaning your web browser, has to go through that page and find out what other pieces of information does it depend on. Okay, it's going to find those pieces of information and also request them from different web servers. Okay, so you can see all of these pages that are downloaded here. They took a long time, but basically by the end, after 27 seconds, I finally got the home page of Ivy League loaded on my laptop. Okay. Okay, so if I do something like a post, right? For example, I type in my Let me see. I don't think I can type it one-handed, but let me try. Okay, and I tried to log in. You can see I generated something else. At the very top of this, I generated a post request, right? The post means I'm going to send that data back to the server. The server is going to react to that in some way. Okay, so it's going to show me the IVLE that I logged into. All of that is at work. Okay, so you can see again what it's relying on. It's relying on some active server pages. It's relying on some cascading style sheets. We'll talk about Bootstrap permission control, I think next week. Okay, and other things like that. Jquery is another topic that Savin will be talking about in week 3. So Jquery is also loaded by the new IVLE to do some interaction with you. Okay. So here's some examples of things that you can see in URLs. So when you use a GET request, many times you can actually see what parameters are being passed. Okay, so for example, here in these web pages, here's a default URL from Steven's class. And then if you wanted to find a particular user, there's a query syntax, right? There's a question mark there, and then a key and attribute value pair, right? Meaning that I want to get this web page with respect to this user with this number, okay? And if I have more than one thing that I want to keep, then I can append additional fields. So this is like, if for those of you who took data structures, this is like a hash table. It's a set of key value pairs that are being transmitted to the server for the server to think about what to do with. Okay, so for example, any of you doing projects related to NUS, if you've joined the SIG NUS channel, you have seen there a list of projects that have been proposed by NUS mod people. Everyone here knows NUS mods, right? Yeah? Yeah? Okay, a few of you are nodding, and the rest of you are sleeping. Never mind. Okay, but NUS mods is a really valuable resource contributed by your seniors. Okay, people about 3 or 4 years back who decided they wanted to make NUS and SOC a better place, and they instrumented things off of IVLE and it spread. Okay. So for example, even in NUS mods, you can do certain things. So I guess you can click this. Let's see whether it works. Ooh, it does. All right. And so you can see some information about certain web pages, certain modules about this, right? So if you look at the URL, for example, this says I'm looking at the timetable of semester 2 for this course, right? But I could change that to some other course. For example, maybe I want to show the course that I gave. See whether this is going to work. I have no idea what it will. Okay, so I teach another module called CS 3245, and hopefully what will show up is that it's taught on Fridays. But here, even on the URL itself, you can see some information of the web that's being sent. Okay, so you can get information from a web page by even sending query items out. Okay, I really wanted to show you that, so let me try to get that page that I. Okay. Oh, you guys stopped playing games. Thanks. Okay. So as I said, get and post are 2 different methods. They're not the only ones, but they're the most important ones because 99% of web requests are about these 2 things. Okay. The important things for you to remember, even though you probably forget, but you'll relearn anyways, is that GET requests are very simple. They're just getting something from a server. Okay? That means very good properties about it. It can be cached. That means something in the middle can store that file and help it deliver it to other people. They can be cached. Okay? They can remain in the browser's history. They show up in the browser's history as a separate URL. Okay? They have certain properties that you should be aware of. So for example, if you're handling user data or sensitive data that is going to change the application state, it means on the server side something is going to change, then you don't want to use a GET request. Okay? You want to use what's called a post request, right? The post looks like this. Okay, when you see a post, okay, it has this form, but you don't see any of these values on the URL. Okay, so for example, when I go to IVLE here, okay, notice that this page here doesn't have any question mark, doesn't have any information about who the user is, what module I'm looking at, etc. Okay, that is because this page, all the information that I wanted to give about who I am, what page I want to look at, was sent by post. Okay, post meaning that I want to change something on the server side. Okay, so I don't have any modules anymore because, of course, this is now special term 1. Orbital doesn't count as a course in our book. Okay. Great. Okay. So I think the important part that you should note is that when you go to a web page, okay, you try to submit something and you try to reload it, right? Sometimes the web browser will say, do you really want to reload this page? I have to send the form data again, right? You've all seen that, right? That means this request was given to the server by post, okay? Meaning that something on the server is going to change as a result of you reloading the page. It means that action has to be tried again on the server. Okay, let's see, how much more do I want to go through? Okay, you probably know already that when you go to a web page that you can type in the name of a host, okay, an internet server, but you can use a host number as well. Those are called IP addresses. Everyone, I think, has heard of them. Maybe you don't know what it is. So for example, this IP address here is also a URL, HTTP, // and you give the domain name or the computer name. So this is the IP address. So if you click that, you will still get back to our school. Okay, you get back to our home page. Okay, but because IP addresses are extremely hard to remember, then you can buy a domain name for your web application. Okay, there's a system out there that's in use publicly. It's called the DNS system. Every time you type in a web address for a page at a new computer, your computer has to know where to find it, where on the web to find it. So it uses this system. It queries some public computers to find out what is the name of the computer as an IP address, as digits, okay, in order to figure out where to go find that. Okay, so I think I've covered everything I want to cover about HTTP now. I want to end up with a couple last things about the model view controller. Then I'm going to try to wrap it up in a nutshell for you. Okay. A model view controller is what a web application currently, a lot of web applications are currently structured like. So you can go to this page, which I'm going to click on here, and hopefully open it up. Okay. So what is a model view controller? Okay. Basically, it means that there are 3 major components in a web application. Okay, and whether you go to Ruby on Rails, whether you go to Python and Google App Engine, or PHP and another framework, you will hit variants of this idea, which we are going to recap for you in software engineering. But it doesn't hurt to learn it now. Okay. So what a model view controller is basically those 3 letters: a controller, the C, the V, and okay. The controller is the middle part. It's basically the logic of the application. Okay. So when you request something, the controller receives it and decides what information needs to be shown to you. Okay. So for example, when you go log in to your email on a website, the controller is going to tell the entire web application that it needs to load the login form view and pass the information of what you set up in your username and password to the model that's going to handle the login. Okay? If your login is successful, then it will pass back the first page that you should see upon entering, such as your inbox, or in my case, the Ivy League homepage. Okay? In a web-based application, the view is what you interact with as a user. Okay? It shows you what's visible. It's the user interface to your application. Okay? How does the view get information to show you? Well, it's given to it by the controller. Okay? So the controller is basically the middleman. It's orchestrating all the things that are going on your web application, and the view is just showing it. Okay? It's the artist that is sketching out the web page for you on the canvas that is your browser. Okay? But it's given all of its paint, all of its data to show through the controller. The last part is the model. Okay? The model is where the data is coming from. Okay? So we already talked about the database, right? The database is where we store information about our application. You know, whatever post that someone made, whatever things they viewed, whether they liked it or not, all those things that you see on web applications, they're stored in the database. In the web framework, there's another software layer on top of that that's called the model. Okay? That is where the database and the web application interface with each other. Okay? So in the database, for example, in IVLE, we will have a table. Okay? There's another database table for courses. There's another database table for forums, etc. Okay? All of those have some tabular structure, meaning some columns indicate what fields it has, and some rows which indicates different records. Okay? That's the database. Now, the model is the software component that allows the web application to interact with that database. Okay? So, for example, in the case of logging into a web-based email, okay, it is going to have to check the data that you send, let's say the username and password, check it against the database record. Okay? The database says, yes, that's the actual user, great. Okay? If it says it's an incorrect user, the model will say, oh, you know, that doesn't look right to me. I don't think I want to authenticate that user. I'm not going to allow him to be logged in. And then it's going to pass that back to the controller. The controller is going to pass an error message to the view to say your name is incorrect. Your username or password is incorrect. Okay? So you can read this post in a little bit more detail. I think it's a good introduction to what an MVC architecture is like. Okay? So my final slide on this is about this part, model and the view and the controller, how they interact. Okay? Where your request comes in. Okay? Actually, when you request a web page from your browser, it first arrives at the controller. Okay? The controller of the web application, by virtue of the URL that you're using to access it, okay, will know what you're trying to do with it. Okay? It will then ask, for example, if you're doing something like posting a form or trying to create content, will interact with the model, okay, to make changes to the database, the underlying database that's going to store information on your behalf, on behalf of the web application. Okay? That information then has to finally propagate through the controller to view the information that you're asking for, right? So you put something on the web server. For example, you in IVLE, you make a forum post, okay? The forum post itself, the data has to get into the database, so it goes through the model. The model is updated, then the controller over here has to create a web page for you to see, right? After you sent the request, that comes back, okay? And that's going to be done through the view, so the controller is going to say, okay, give me the view that I should show after you submitted the forum post. Okay, then the view is going to render itself and then use any information from the model that's gotten changed to show it. So for example, it'll create a web page that shows you your post, right? So all the information that you stuck in the database with your form information will be then pulled out of the database and shown in the view that's rendered on your screen. Okay, so that's all I have for you for this section of the course. I know it's a lot of technical detail to get. We don't expect you to understand it, okay? But the important part, again, is to give you a holistic idea of what's going on the web interface, okay? So, yeah, I'll follow up with that later on. Okay, we're going to take a 5-minute break. At this point, we have 2 sessions that are going to start. Okay, we have here HTML and CSS. Okay, where we're going to go over Code Academy exercises. They'll be interactive. You'll only need your computer and a web browser to do this. Okay, and for those of you who've already downloaded and installed Android Developer Studio, you can go next door to the seminar room where Jquery will be able to talk through. Okay, so we're going to start on both sides at about 16:40, so about 10 minutes from now. Okay, thank you.